Okay, so in 5.1, we talked about writing expressions, taking real world problems and putting mathematical symbols to them. And today we're going to talk about how we can simplify those. And just like the word simplify means to make it simpler. So I like to call this one, everybody wants a special name. So how can I name the parts of this expression? So if I'm looking at this is an algebraic expression. We have our number, our variable, and our operations. But everybody wants a special name. So I know you're thinking, that's a 4, and you're right. I'm multiplying by the variable a. This is an addition sign. This is a 7. This is the variable a again. It's addition. This is 1. But they're not happy with those names. They want something more specific. So mathematicians made them happy and gave them additional names. So the first thing we're going to look at is these are all called terms, where they're the parts of an expression that are added together. So this is a term, 4a, 4 times a. This is a term, and this is a term. Okay, but they still weren't happy. They're like, no. The 4 is like, I want to be called something special because I get to hang out with this a, so I should have a special name. I'm not a 4, and I know I'm a term, or I am a 4, but I want something special. So they came up with this term called coefficient, and that is the number that multiplies the variable in a term. So I like to think about the coefficient. The co helps us to remember it's the co-pilot. So if I look up here, the number that multiplies the variable. So I have a 4 and I have this 7. So my 4 and 7 are the coefficients. And they're happy now because they're like, I am hanging out with this variable. I should have a special name. And so we're like, all right, you can be the coefficient. So they're the coefficient. Now, it's also important to remember that if I had the variable, let's say m, and it was all by itself, there really is the coefficient of a 1 in front of it. So if you see a variable all by itself, let's say it was the variable n, and you want to write a 1 there so you can see that that's that coefficient, feel free to do so. It's always there. We just don't write it unless we need to. So then the 4 is happy. A already has that special name with the variable, but the one's like, I want a special name. So they came up with a special name for him. It's called a constant. And the reason I like to say he's a constant is the way I remember this is he's constantly alone. So there's no variable that he is attached to. Okay, so it's a constant. It's something that's. And then we come up with like terms. And I know you're like, oh, One Direction. So like terms, what's in common between these? Oh, they're wearing the same shirt. So like terms have identical variable parts raised to the same power. And I like to think about this like we totally have the same outfit. And my husband likes to count how many times I say like. But so like terms, we like to identify what our like terms are. So if I was to go back and look at this, 4a plus 7a plus 1, like the ones totally with the same outfit would be the 4a and the 7a. So they have the same outfits. So those would be considered like terms. I hope that helps. So one of the things that we're going to have to do is identify the parts of an expression. The first thing, so here we have our expression right here, 5x plus 2 minus 7x minus 3. The first thing that we want to do is get rid of these minus signs. So we have to remember our keep change change. So I'm going to write it as 5x plus 2 plus negative 7x plus negative 3. Okay, so basically all I did was rewrote it as an addition. So we have our terms we need to identify, our like terms, our coefficients, and our constant terms. So I like this photo because they look kind of similar in here. And so the terms that we have would be 5x, 2, negative 7x, and negative 3. So I'm just going to write that down. We have 4 terms. Our like terms are going to be 5x and 7x. So I'm going to write 5x and negative 7x. Our other set of like terms is going to be 2 and negative 3. So 2, negative 3. So we have 2 sets of like terms. These two have the same outfit, and these two, you can think about having the same outfit because there's no variable there. Our coefficients, remember, is the co-pilot, so it has to be with the variable. So if I look up here, I can see that the 5 and the negative 7 are going to be our co-pilots, our coefficients. And then our constant terms, the one that are alone, are going to be 2 and negative 3. Okay, so that's part of the process, is just identifying these vocabulary words, what our like terms are, what our coefficients are, and what the constant terms are. And Miss Peterson likes to call this circles and squares. So she'll put squares around terms that have the same outfit, so to speak, and then circles with the other terms that have the same outfit. Okay, so let's take a look at these ones and identify the terms, the like terms, the coefficients, and the constants. So again, the first thing I want to do is write it as a sum. So here we go. Negative 3a plus 4 plus, I'm going to change this to its opposite, so it's negative 6a plus the opposite of positive 4 is negative 4a. So our terms are negative 3a, 4, negative 6a, and negative 4a. Our like terms, the one that have the same outfit, I'm going to go ahead and put squares around those. So I have a negative 3a, negative 6a, and a negative 4a. Okay, so I'm just going to put negative 3a, negative 6a, and negative 4a. These are our like terms. If I had another constant out here, I could say that those two were like terms, but there's nothing else. The 4 would be by itself. Our coefficients, oh, they're right here. We can take a look at those. It's going to be negative 3, negative 6, and negative 4. And then the constant terms that I have, I only have one in here, and that's going to be 4. Okay, so again, the process, half of the problems are going to be just identifying what our like terms are, coefficients, and our constants. We're kind of like, is that all we're going to be doing? Yeah, no, you're in 7th grade, so it's going to be a little bit harder. And we're going to do what we call, because the whole point is to simplify it. So we call that combining like terms. And we can only combine terms with the same variable raised to the same power. So again, like terms only, like they have to have the same outfit. So there's a couple of steps we're going to take. I'm going to go ahead and write them out, and then we'll go through them. And we've talked about them already. So the first one is the keep change change. That's changing our minus to addition. And then we're going to do our circles and squares You might have to do other symbols as you progress in math and as you get, like they might have 3, 4, 5 different variables. And then we simplify. So let's see what this looks like. So the first thing I'm going to do is keep, change, change. So I'm going to rewrite this as 5x plus 2 plus the opposite of positive 7 is negative 7x plus the opposite of positive 3 is negative 3. Okay, so I just did my keep, change, change, and I got rid of all the subtraction. And then I look for my circles and squares. So I'm going to go ahead and say, oh, they have the same outfit. They also have the same outfit. 2 circles here, circles here. Now, simplify means that I squish these guys together. I make them as simple as possible. So what I'm going to do is rewrite this as 5x plus negative 7x plus 2 plus negative 3. So basically what I did is I used the commutative property and the associative property just to mix these guys around. So I can put them, all the ones with the same outfits together. So if I look at my coefficient, I have 5x plus negative 7. 5 plus negative 7. That's going to give me a negative 2x plus the 2 plus a negative 3. So this is where you're going to have a kind of get in some trouble if you forgot how to add your positive and negative integers. So 2 plus negative 3 is going to give me negative 1. Okay. Now, they don't have the same outfit, so there's nothing else I can do. This is my final answer, would be simplified. So if you look back at my original expression up here, I simplified it down to an expression right here. What I'm going to do is look for my like terms. So like who has the same outfit? We have the 3a, we have the negative 6a, and we have the 4a. So I'm just going to rewrite that as 3a plus negative 6a plus 4a plus 4. And if you want to count too, like to make sure we rewrote them all, you can do that too. So 1, 2, 3, 4, I have 1, 2, 3, 4. So I'm taking care of all the terms. Now I can only combine the ones that have the like term, which is the variable. So I'm going to look at the 3, negative 6, and 4. So you could kind of think about it as 3 plus negative 6 plus 4, then I'm going to end up multiplying that by the a plus 4. So 3 plus negative 6 is negative 3. Negative 3 plus 4 is going to give me 1a plus 4. And again, if you don't want to write this one, you don't have to. You could just rewrite this as a plus 4. Okay, but there's nothing else I can do. I've simplified it enough. Remember, you can only combine your like terms. These two are not like terms. This one doesn't have a variable with it. And so that's it. I've simplified this expression to this. Nothing else to do. So again, first thing I want to do is do my keep, change, change. This stays as a negative 7m plus negative 3m plus 2. I'm going to do my circles and squares, or squares and circles, however you want to call it. Okay, so we have negative 7m plus negative 3m. That's going to give me a total of negative 10m plus 2. And there's nothing else to do. That's simplified, and that's it. Now, they may ask you to evaluate it when m is 1, and then you would solve it and get a final answer. But for right now, there is nothing else I can do. All right, I just wanted to throw this in here because we're going back to that distributive property that we all should know and love. And what that is each term is going to be given a hug by the number outside. So it's I can rewrite this as 2x plus 2 times 5, which is 10. Okay, and so basically you could also think about it as you would have two sets of x plus 5. So I'm going to have x plus 5, and then I'm going to have an x plus 5. So, oh, I have two x's, which is I have right here, and then I have a positive 10. Okay, so that's it. That's all you can do. And we want to use our distributive property, distribute the love. So the 3 is going to give a hug to the x. So I'm going to rewrite that as 3x plus 3 times 2, which would be 6, minus 4x. Now going back to our goal of simplifying expressions, I want to get rid of this subtraction sign. So I'm going to rewrite it. There's 3x plus 6 plus negative 4x. I'm going to go ahead and box the like terms. I have the 3x and the negative 4x. Okay, so 3 plus negative 4. Okay, got to go back and remember you're adding and subtracting positive and negative integers. So I have $3, but I owe my mom $4. So that means I'm only going to still have to owe, I'm going to have to owe her $1. So that's going to be a negative 1x plus 6. And again, you don't have to put that negative 1 there if you don't want to. You could just write it as negative x plus 6. But a lot of us like to see this one out here, and it's not hurting anybody, so it's okay to go ahead and leave it like that. All right, so we're going to get practicing on this, and I think you guys are going to do just great.